Hernández. I am the Head of Computational Design and Projects at ShapeDiver. And today I'm going to talk to you about how to democratize computational design via cloud-based applications. As many of you know, one of the main softwares to create computational design nowadays, or the most known ones, is Grasshopper. So I want to talk to you about how to democratize computational design through Grasshopper and through cloud-based applications. Grasshopper has been around since 2007, but I got to know Grasshopper until 2014 when I was doing my bachelor's in architecture in Bogota, Colombia, my hometown. Yesterday there was many Latin Americans here as well, so that was very nice to see so many Latinos here in the community. Back then, my teacher was from Canada, so the class was in English, and I didn't have a very good English. My English was not very good looking. But even though my English was very good looking, I was able to manage to see the potential of Grasshopper and managed to do some of these little projects in 2015 when I was introduced to it, where we did even some a little bit of digital fabrication, where we were like unwrapping, and we were nesting, and we were doing the laser cutting. So even though I had this English problem, I was really able to see the potential of Grasshopper. But a year later, I decided I wanted to fix that problem. So I went to Australia, and then I spent there 2 years. I was not just learning English, but I was also doing a bachelor in computer animation. So here is just a little thing that I did for animation purposes. And I was also doing some freelancing for housing, especially doing some drafting, some 3D modeling. And finally, I was also teaching some architectural students ArchiCAD. To pay my bills, I was mainly doing the housing part, doing those drafting and 3D modeling. However, that has a lot of competition there, so I was not able to do much money there. So I had to specialize in something else, and there is where I started to get a lot of clients in doing the sheds, like this big, like the place that we are right now, places where normally it's used for farming or like industry. And well, in Australia, there's a lot of space, so we call it farming. So I started to get clients more in this kind of industry, not just in Australia, but also in New Zealand. And with this, I was able to automate a bit process, my process of creating these drawings, because these kind of buildings are very standardized. So I had some templates. I was able to optimize my processes and to make more profit from it. But then I started to see that, well, if they are so standardized, then I could potentially do even more automation and to give somehow a way of the clients themselves to easily change their shed, change the parameters of the shed. So I started looking into solutions to do that, and well, the best way to do that is via a browser. So when I was doing computational animation, then I learned this tool that's M4D, Blender, 3ds Max. All of these are mainly for animation and gaming. And then I also was introduced to something called SketchFab, where you can host your 3D models so that anybody can interact with them. So it's like before we had MP4 files and our videos in our computers locally, but we were not able to share them to everyone. But now, when YouTube appeared, now we were able to do that. So SketchFab is the same YouTube, but for 3D models. And through their API, I was able to create different kind of configurators where I was able to change materials. I was able to do even a bit of modular, hiding, showing things, and even faking a little bit of being parametric by like overlapping objects or stretching objects, things like that. However, well, this is done with explicit modeling, so basically I have to actually model the objects, and it's just one at a time. So it's not very, it's not really parametric. No, I'm just faking. So I started to see the bottleneck, and I wanted to make this even more powerful. So 2017, I was like, there's going to be a better way to do this. I want to make tools that are more powerful, and I also want to even extract the information from these 3D models, not just visualize them, but actually create some processes from them, some maybe structural analysis, etc. So I already knew SketchFab, and I remember that while I was studying architecture, I was introduced to Grasshopper, but then I was missing that link to the web. We have SketchFab for 3D models, for YouTube, for videos, and then what we have for Grasshopper. So after a little bit of research, then I found out that, well, that already exists, and that was ShapeDiver, and well, that was in 2017. So how do we convert this, the spaghetti monster of Grasshopper, into the actual 3D application, an application that anybody can access through a browser, and well, they don't have to deal with the complexity of the Grasshopper model itself. So here we have our computational designer in their local machine, and now we need to put that into a server to begin with, so that anybody can access this model. And how do we do that? So in 2019, Magni introduced a Rhino Compute, and that basically helps you do that, run Grasshopper in the servers. However, ShapeDiver has been around since 2016, and you can see it in 2015 when the idea was born. So, well, basically, we didn't have Rhino Compute. So, through all of these years, now 10 years, we've been able to figure out the best way to run Grasshopper in a server. And for example, things like what happens if you have hundreds and hundreds of users that want to use the Grasshopper script, the actual final application, and how do you do to serve each of them efficiently if they want to use, for example, the same model, or what happens if they want to use multiple instances of Grasshopper? How do you dispatch that so that you can scale up your servers, you can scale up the use of Grasshopper without overblowing your servers? You have to initialize one instance of Grasshopper every single time that somebody wants to access it. Well, no, that will overflow your server. So that's why we have an algorithm. We have the queuing theory, and then we're able to really dispatch efficiently and at scale the use of Grasshopper. Well, now we're able to run Grasshopper in a server, but now we also need to display the geometry in the browser. Now in Rhino, you normally have your Rhino viewport, but now we need to display that geometry but in a website. So how do we do that? Now we have something called WebGL. This technology allows you to do that, to see the 3D models in a browser. And on top of that, you can use these frameworks like Babylon.js or 3GS, which allows you to map the geometry that you normally see in Rhino, map it into geometry that you can see in a browser. In our case, we use 3GS. So now you can run your personal servers, you can display the geometry results, but now we need to give access to the parameters, the user interface. So all of the sliders, drop-down menus that you normally see in Grasshopper, how do you expose that in the browser? So in one route, you could use web frameworks, so regular CSS, HTML, JavaScript to create all of your sliders, all of your drop-down menus, map what you get from Grasshopper into the browser. Or on the other hand, if you want to stay within the computational design field and you don't want to start coding, then you can use our plugin, the ShapeDiver plugin, which has a section called App Builder, where you can not just, so with Grasshopper, you cannot just design what the user would see, the final result, the final calculation, but also the user interface itself. So you can decide, okay, I want this slider to appear in the left side menu, the right side menu, the left side, or I want this exact parameter to be shown when X or Y happens, so conditional, and all of that through Grasshopper. And also whether you want to show tables with information, whether you want to show graphs, etc. All of that can be done only by using your Grasshopper skills. Okay, now we can run Grasshopper in a server, we can display the geometry results, we have given access to the parameters via user interface, but now that we're already in the cloud, we're already in the browser, so to make this even more powerful, we can start to connect to other services, for example, via APIs. And we have our own APIs, so you can do that connection to these external services. So we have a viewer API, a backend API, so you can connect to our servers, a platform API, and you could connect potentially to any of these services. But if you don't want to also do some coding, but you want to stay again within your computational design skills, then you can use also some plugins that we have already developed, so that you don't have to do any coding at all. So for example, we have an integration with Shopify or WooCommerce if you are into consumer products, so if you sell rings, furniture, kind of things, and you are a great computational designer and you want to sell those products, you can do it directly just by using our Shopify or WooCommerce integration. Or if you are in the AC industry, then many of you may know Speckle, where you can then from ShapeDiver push information into Speckle, and then from Speckle push it to Revit or push it to TechCloud or any other of these AC software, or even an integration with OpenAI, so you can start using some artificial intelligence with your models. How do we use it? Using artificial intelligence, so you have a video where you are creating the UI and everything in Grasshopper. Then you have this ring that you then connect with just an ID to our Shopify plugin, and then here we are already in Shopify. And then all of these parameters were all defined in Grasshopper, so the user can either start to click on the parameters in Grasshopper, sorry, in the user interface, or there is a second option where you can have like a chat bot that is basically OpenAI in the background, and you can start to request changes in your model. So it's going to happen in a bit. And, yeah, there we go. And then you can write, okay, I prefer the X method or whatever, and then we have the context of all of your parameters because they come from Grasshopper. Plus, you can give extra context through Grasshopper. So ShapeDiver is works with 12 plus different industries worldwide, and some of those industries specialize or they use additive manufacturing. So for example, eyewear, footwear. For example, for footwear, we have Vivo Barefoot. And in Vivo Barefoot, for example, use ShapeDiver to help accelerate the process of generating the best last. And here we have a small video of one of the latest products that they are releasing where they are actually creating the entire shoe 3D printed. And they use also ShapeDiver to help the user do some final design decisions in the process. Then we have side B in concrete 3D printing. So here, for example, is an example in the Netherlands, which they use the concrete 3D printing. And in this case, we also use ShapeDiver to give access to the Grasshopper files so that people can do some design decisions on their own as well. And then we have OrthoSolid, which is here with us today, and then they will tell us about how they use ShapeDiver.
Thank you, Edwin. So, let me start off by introducing you to Mr. Vergaal over here. He's an orthopedic technician in Belgium, and he creates custom orthopedic devices for his patients. How it works is he sees many patients, let's say in the morning, and then afterwards he creates all his products inside this atelier. If he wishes to expand his business or grow his business, he would have to expand his atelier capabilities, which is very expensive, and also find new personnel to create these devices manually. Even if he does those two things, finds the new personnel, traditional methods of creating orthopedic devices are still very manual and quite repetitive, and thus difficult to scale up. And he's not alone in Belgium. The whole sector in Belgium, and I've also gathered information from the Netherlands, is that demand is increasing for orthopedic devices, but personnel availability, qualified personnel availability is actually slowing down. All that while the work that they do remains really repetitive and thus difficult to scale. And so OrthoSolid is able to fill this void by completely revamping their traditional workflow. We offer modern measurement techniques like 3D scanning. We of course offer modern future-proof production product creation tools, and then we combine those with modern production techniques, i.e. 3D printing in our case. And so all this is sort of gathered and compiled by our computational models and parametric models which we have Grasshopper and bring to life in ShapeDiver. Now this might sound all a little vague, so just let me show you how we make a little Let me show you how a 3D printed thumb speaker is made in our platform. So as you can see, some data points are placed, and trim lines can be adjusted really easily by dragging the points and defining the trim lines. After this, the brace is generated automatically, and our orthopedic technician is able to choose a bunch of options to fine-tune the design for their patient. They see a final preview of the product, and then they order inside of our web application. And so, as you saw in the video, clients are now able to semi-automatically create these devices and do the same or even better quality, and they're able to do this in a shorter amount of time. Also, investments to start are kept really low, both in terms of the learning curve, which is really important in the sector, and also financially, also really important, as I've talked about before. And so, this offers clients like Vergaal a really interesting opportunity, because now they can scale their business without big investments, nor compromising on quality of these devices. And so, this workflow also offers us as a business really important advantages, scalability being the most business advantage. But for me, as a designer, I have both control over the parametric model inside of Grasshopper, and maybe even more importantly, I have control over the actual UI and UX that we have on the platform, all human. And this ease of developing these tools is really important, because this means that we can also evolve OrthoSolid over time, and so we can grow together with our clients as they grow in expertise as well, since it's really emerging markets. And so we try to strike that balance between the control that we offer in our Grasshopper models and the ease with which we can deliver this to our clients. And so I hope you can see where I'm getting to. Offering these computational or parametric models or designs directly to end consumers, or in this case, orthopedic technicians, is not so much about how complex or advanced I can make my model. It's about how we can make these tools accessible to people who use them to help their patients. And that's their ultimate goal, and also our ultimate goal. Thanks.
We are back there in that room, so in case you want to know anything else about ShapeDiver or OrthoSolid, we can tell you more about it. Thank you very much.